Hi, I'm going to show you in this video how to make a complete mod for Airships Conquer the Skies from scratch. So I'll be doing this on Windows, and I'm going to first show you what kind of tools and resources you want to put this stuff together. Basically, the two tools that you need is a graphics program that supports transparency and a decent programmer's text editor. So I'm going to be using, for the graphics, I'm going to be using GIMP, but most like pixel art sprite drawing tools will work as well. And for the text editor, I'm going to be using gedit, but for example, you could also use Notepad++ or something like that. And I'm going to go with the assumption that you have Airships installed on Steam, though honestly not really very much changes if you have it installed outside of Steam. So the plan is to make a relatively simple mod that adds one new module, which is a kind of pod of small rockets that fire rapidly. I'm going to start out by creating the graphics for that, because if you do the graphics first, then we can do the actual data based on those graphics. Okay, the other resource which I'll make available for download, which is going to be useful, is this file. This is modgraphics.xcf. So if you are using GIMP, this is basically the all the various bits of the graphics you will need to put things together. And there's basically three bits that we have to make. We have to make the actual graphics. We have to make the bump map, which will show the lighting engine, how to light it, and finally the fragment map, which shows what should happen when the module is destroyed. So we're going to start out by actually drawing the sprite sheet, and so that has to go. The graphics have to go against a transparent background, and all of the graphics for modules are on a grid of 16 × 16 pixels. And indeed, I just added a grid like that in a separate layer here at the bottom, so we can use that to guide our drawing. And here in the top right, this is unhelpful. In the top right is the official color scheme. We can see what the various colors are used for. Which is, it's good if you stick to that one, just because that will mean that your graphics kind of mesh well with the graphics of the rest of the game. So for our rocket pod, we are going to start out with just needing a wood color. We're going to go over to the top left here, zoom way in the top left, guess that much. I'm just zooming this in a lot so you can see it more easily. And now we're going to pixels on pixel graphics with this brush. Okay, so I'm going to draw the floor first of the module, and then I'm basically just going to draw a little stand where the which is going to hold the actual pod of rockets, like that. And I'm going to draw a little circular kind of, I didn't want it like that. I'm just going to pixel it. Going to draw a little circular kind of bit which will hold it and rotate it. So, and that's actually the graphics for that done. And we need two other things. We need the actual projectile, and we need the barrel it shoots out of. So for the projectile, now we're zoomed in. For the projectile, I'm going to pick red as the main color. Just going to draw it below. small rocket like that, and we'll make the we'll use this dark color for the tip and the fins. Okay, so little rocket, and then we also need the actual kind of holder where the rocket shoot out of. I guess that should be made of metal. So let's pick steel color. Now I'm going to draw this a little bit to the right for a very specific reason, which you'll see later. Like here. Then I'm actually gonna take the tip of this rocket and like show that there's like these rockets are sort of sticking out a little bit like that. Okay, so that's actually all of the basic graphics done. So the idea is that this is the holder, it's going to hold this thing. Looking at it, it totally has to be a bit higher. And then these things are going to shoot out of this thing. Okay, so that's the basic graphics done. Now we have to do the lighting stuff. And to do the lighting stuff, we basically use, we create a second image, and each color channel indicates something different about what the graphics are actually going to look like. So we're going to turn on this whole thing, and it just turns everything into this ugly greenish beige color. And there's some instructions here actually. So there's 3 color channels. There's red, green, and blue. And the way it works is that the blue channel is responsible for how strong the lighting is. So metal is like reacts more strongly to lighting than other things. The green channel is the horizontal direction of the surface. So you just look at the graphics you've drawn and you think about in which direction is this particular pixel pointing. Is it pointing left, right, towards the player, whatever. And the red channel is the same thing for the vertical direction. So there's not actually any cleverness or artistic talent involved in this at all. You just have to think about what is the 3D shape of each of this. And to be able to actually put this together, we're going to set the opacity of the entire thing down to 50%. So now we can see it's sort of layered on top of it. And we're going to start out with, I guess, the blue channel with how shiny stuff is. And so we're just going to take the colorful metal from here. So that's a sort of a light, well, it's a kind of a mid blue. And we're going to paint everything that's made out of metal in that color, which in this case is exactly this rocket holder. And that's actually our blue channel completely done. Now horizontal is a bit more complicated. So we don't really have anything that really strongly slopes, so it's just going to go for facing left. So everything is defaulted to normal amount of lighting facing straight towards the player. So we'd only have to draw different colors for when it's actually doing something different. So here, everything that faces left. So what faces left is that side of this holder, that side of this pod, and arguably like the butt of this missile. And yeah, that's all. Then we need facing right. Okay, what faces right? that, the entire front cone of the rocket. There we go. And then we repeat this whole process with the vertical channel. So stuff that's facing up. So stuff that's facing up is a lighter red. You can really think of it as just, also you can think of it of like drawing it as if there was a red light coming from the top. And so that means here, that means these places, and it means here. And then finally, the bits that are facing more downwards than upwards. Don't worry if this is going a bit fast, I'm gonna go over everything again in a moment just to explain the logic behind what each bit is. Okay, so that's everything done. So I'm going to go through the color channels again and just explain how this all works. Okay, so shiny, that indicates how strong the lighting effect is, and most of this stuff just has the normal blue color, except for this bit here, which is made out of metal, which has a brighter color to indicate that the lighting should be stronger on it. Then the horizontal angle. So things are kind of a mid-green if they're pointing straight towards the player, a stronger green if they're pointing more left, and a less strong green if they're pointing right. And so you can see that here with this box here, the left edge is green, the right edge is less green. And then finally, with the vertical, it's exactly the same logic, except for that time, the stuff that's more pointing up is more red than the stuff that's pointing down. Then finally we can combine all of these three, and then we get this sort of effect that looks a little bit like green lights coming from the left and red lights coming from the top. And if we then set the opacity of that back to 100%, that is the second of our image completed. That's the image for the bump map. So there's just one thing left now, the third image that we have to do, which is the fragment map. So I'm just gonna set, yeah. And so the fragment map, just for module graphics, is there to indicate when it breaks apart, it produces fragments like parts of the picture of the module that kind of fly away, and it also uses it to show a kind of a damaged version of the module. And so you basically look at the graphic you drew and you think about, well, if this was to be destroyed, which bits would sort of break off from the other bit? Like, would it splinter into pieces? Would this entire thing fall off or something like that? Now here this is sort of boring because honestly there's hardly anything in the module. So I'm just going to pick red. So it's just going to pick red as a color, and I'm just going to color in, this isn't red, red. There. I'm just going to color in the entire top here as being of this red color. And what that means is that if this module gets destroyed, this whole bit here would fly off as a fragment. If you had more complicated graphics, you would pick more colors and make this sort of map of different regions that it would splinter into. It doesn't really matter which colors you use. I tend to just use red, green, blue, and so on. But you can use as many as you like. Yeah, so that's the fragment sheet done. Okay, so we've done all the graphics for this, but now of course it would be nice to actually create a mod as well. So first, we're just going to export these 3 bits of graphics into files. And again, we're going to start building up the mod on the basis of these graphics. Just going to export this as cluster rockets fragments.png. So export everything as PNG. And very importantly, when you export the sprite sheet, make sure to get rid of any background you have, so that all the bits, so that the background is transparent, right? Because otherwise it's going to draw that, and you're going to get like whatever background you have in the background of the module instead of the armor being drawn, and that's going to look really bad. Okay, so we export this final bit, which we'll just call cluster rockets. As a PNG, and that's the graphics done. I'm going to leave GIMP up because, I'm going to leave GIMP up because we'll actually want it again later to do some measurements on the graphics. And we left in like the instructional stuff, which honestly doesn't matter. I mean, ideally I guess you delete this out, but it doesn't matter. Okay, so the next section is actually putting together the set of text files that creates the mod itself. Okay, so we'll start out by creating a folder which is going to hold our actual mod. And we should think of a unique ID for our mod at this point, which should ideally just be like letters and underscores, and just call the folder that, and that's also what we'll use for the ID of the mod and for prefixing other stuff and so on, just so the game knows, you know, so it doesn't collide with the IDs of other stuff. So if you call it my mod and someone else calls it my mod, then the mod loader will get confused. So we'll name it after what it actually is, which is cluster rockets. Okay, so yeah, just create a directory. And then inside that, we now can put our images. So that just goes into a folder called images. Okay, at this point you might be thinking, well, you're telling me about how to do this particular mod right now, and that's nice, but what if I want to do anything else? You know, what if I want to do something slightly different? How do I find out how to do any of this stuff? And the answer is, well, the data format for mods is exactly the same as the data format for the game itself. And so you can just go to your game install and look at the data folder there, and it's all the same. So I'm just going to show you how to do that. If you have the game in Steam, you can right click and hit properties, go into local files and hit browse local files. And there we go, that's the game install. And the folder you want in there is data. And so this is all the data in the game. There's some extra stuff in here which you know, shaders and so on. But for example, as you can see, there's an images directory as well, which contains all the images for the game. There's, for example, a module type directory, which contains all of the modules that the game actually has. So you could actually, instead of creating a mod, you could just edit these files, but you shouldn't. But all the mod loading does really is that it loads in the original data and graphics first, and then it loads your mod on top of that, overwriting and adding anything you put in there. So if you want to figure out how to do anything to the game at all, just go into the data directory, have a look at the folders, have a look at what the data looks like in the folders, just make a mod that like changes that around, and then you'll see what happens. Okay, so and that means we have some images. They should go into the images directory. Okay, so what's the second thing that we really need for the mod is we need a we need a file called info.json. So data format that Airships uses is called JSON, JavaScript Object Notation. If you don't know what it is, you can read up on it. But it's fairly straightforward, and it basically just lets you edit all the data in a text editor. And so what we need to do is we need to create info.json, and that looks something like this. So we specify the ID of the mod. Then we specify the name. Now this is mildly tricky because like the game is fully multilingual, right? So you can't just say this is its name, you have to say this is its name in this language. For now I'm just going to do everything in English, but you can do any number of language codes. So, you know, if you have the skills, you can do it in like also in French and German and Russian, and then everyone gets to use it properly. But if not, it will always default back to the English description. So if someone set their game to be in French, but your mod only has English, then they just can have a few bits of English in their game, which is better than it not working, right? We're going to call the mod class to rockets. And then finally, we also need the description, which works in the same way. Okay. Probably doesn't matter, but it's probably better if you set the line ending to Unix. Don't worry about this, actually. I'm pretty sure it works either way. Okay, so this is the info file. And now we actually have a mod. This will now actually be identifiable as a mod by the game. It just won't be super pleased about it because there's nothing in there. Oh yeah, the final thing that we do really want is we want a logo or a picture of the mod. This is a catch-22 because obviously we kind of need the mod to make a screenshot so whatever. Right now we're just gonna do a quick ugly one that can stand in. Incredibly ugly, painfully ugly. There we go. Amazing. And the logo is always at logo.png. So now it has a logo. It's the worst logo ever, but that's okay. Okay, now with all of this done, we can actually start up Airships and we can load in the mod and it will do absolutely nothing. But it's a good point maybe to do this right at the start just to check whether you got the basic framework of it right, because if you haven't, you can fix that first. I'm going to start up Airships and then go into settings and info and mods. Then you can click install mod. And that gives you a file chooser dialog, and you can see now we're on the desktop and cluster rockets is treated like a file because it knows it's a mod, and that's because it has a info.json file inside the folder. Okay, so we install this. It generates, well, every time you do this, every time you install a new version, you go through this generating graphics step, which just makes sure that all the graphics are correct. Okay, and once that's done, we can now see it here in the list with our really rather ugly logo. And we can see down here the description. Now, if anything had gone wrong with the loading of the info file or anything like that, or later if anything goes wrong with the data files, it will actually say down there, it will have error messages, so you can check that out to figure out what's going wrong. Okay. So now let's actually make the mod itself. Let's put in the data for it. And the way we are going to do this actually is we're going to cheat a little bit and we're going to steal. Because, hey, I can't remember immediately what all of those parameters do. So if you are creating a new module, honestly, the best way of doing it is pick the module from the existing data that's most like the thing you want to make. Oh, it ended up on the desktop rather in here. Okay, that should be working now. Take the module that looks most like the thing you want to make and just copy paste it in and edit it, right? So let's go into the data directory again, and we want module types. And obviously, like our small rockets are going to be pretty much like the big rockets. So let's take the rockets file, copy it. Then we need to create a module type folder in here. Paste it in. We're going to rename it to cluster rockets. Oh god, now we're going to open it in gedit. Okay, so this is now all the information that actually comprises this module. Okay, so it has two records really. It has one big record which is called rockets right now, and there's another smaller record which is called flipped rockets, and that just says flipped from rockets. So most weapon modules have flipped versions of themselves, and instead of having to type in everything again that almost identical but with some crucial changes, you can just say please look at this other module type and flip it around for me. And I guess we want backwards facing flipped cluster rockets as well. So we're going to say this flip cluster rockets, and they will be flipped from cluster rockets. And what are cluster rockets? Well, that's what we're talking about next. Okay, so I'm going to go through each of these fields, describe what they actually do, and edit them as required. Okay, so categories is in the editor itself. You have a set of different categories, such as weapons, troops, basic, and so on. And this is just a list of all the categories it should go into. Then the second thing is required. That's an optional field that lets us say a certain bonus is required for actually having this. So in this case, the bonus called rockets. Now, bonuses sadly are one of the few things that are currently not moddable. This is something I want to fix, but it's a bit complicated because some of the bonuses have very specific effects that have to be kind of programmed in. So just because we want to try it out and whatever, let's just remove this. So we don't need any special technology essentially. The next is weapon. Well, yeah, it is a weapon. Then we have the width and the height of the module. Now, note that some of the numbers here are going to be in pixels, and some of the numbers are going to be in tiles. Tiles are 16 pixels. So here we're talking about tiles. So the module is 1 times 1 tile. Next is the appearance. Now, the way appearance works is that it points at a particular image, at a particular sprite sheet, which I will create in a moment as well, and then points at a particular part of the grid. Now, right now this is pointing at the default sprite sheet, but of course our pictures aren't in the default sprite sheet. Our pictures are in cluster rockets. So we're going to change that to cluster rockets. And where is the picture? It's in the top left. And it's 1 times 1 tiles. Okay, next up, HP. How many hit points does it have? Now, 80 is for a module that's 2 times 2. It's kind of low for a module that's 2 times 2, but it's obviously too much for a module of 1 times 1, so I'm going to take this down to like 24. fire HP is at what point how damaged does the module have to be to maybe start catching fire. So the higher this is, the more likely it is to catch fire. You can even have it higher than like the maximum hit points, like the coal store, for example, has like more, and that makes it really flammable. Now this is obviously too high at this point, so let's take it down to 20. 20 is still pretty high, but hey, we're dealing with flammable materials, so that makes sense. Move delay is how many milliseconds does it take for a crew member to walk through this module. 800 is the default value for modules that have stuff in them. Like corridors have, I think, 300 or something, and decks have like 150. So the main point of corridors obviously being that you can move faster in them. So 800 is a normal, sensible value for this. Next thing is weight. Again, 30 is actually low. Obviously, when you're setting these values, do look like at what other modules do for these numbers to pick numbers that make sense. So I'm going to halve this, actually set it down to 12. How much does it cost? Well, I want this to be quite the cheap and nasty kind of weapon, so I'm going to take this down to 10. How many crew does it take to operate it? So obviously, if the module is manned by no one, then it doesn't work. And if it's manned by, say, only half the people, it will work at half speed. So in this case, you only really need one to operate this. Recommended crew. Now, some people got confused about this already. What recommended crew means isn't the recommended number of crew for manning it. It's the total number of crew that the ship should have to properly support this module. And what this means is that while the crew is 1, the recommended crew is 2. Why? Because you need a second crew member to deliver the ammunition, ideally. If you don't have someone to deliver the ammo, then the guy who's operating it has to go back and fetch ammo all the time, and it's not going to be that effective. So ideally, in a fully staffed ship, there are 2 people for this one rocket thing. Next thing is windows. So that's a list of the tile coordinates starting at the top left of where the windows are. So the rocket module has a window in the bottom right. We could give this a window in the one tile it has by setting this to 0, 0. The next value is can occupy. So that gives us the coordinates of all the tiles within the module that crew members can actually walk into. And now this is set to be the top left, the bottom left, and the bottom right in the 2x2 module, because there's a ladder in the left, but there's no ladder on the right, so you can't get into the top right of the module. Now here we don't care because it's only 1x1. You can get rid of this whole thing because the default is that you can occupy all bottom tiles anyway. Equally, you can get rid of left doors and up doors because the default is that there's doors, and the default is that there aren't hatches going up, which is the correct thing to do. The module doesn't have a ladder, so it shouldn't have a door up, and hence it can just have the default door to the left. Okay, what about doors to the right? Well, next thing is front only. So there's front only, back only, top only, and bottom only, and these restrict where you can place the module. So front firing weapons have generally set front only to true, which means that you can't have another module in front of it. And we can leave it like that. Turrets, for example, have maybe front only, back only, and top only set to true because you need to put them on top of the module and you need to have a 180-degree field of fire. One of the ways you can make modules, one of the considerations when designing a well-balanced module is what are the placement restrictions. The more restrictive the placement, the worse the module, right? Because you need to account for that. So you can, a module that is harder to place can be a bit more powerful, essentially. Okay, next thing is explosive. That's just the flag Oh god, I think that's just a flag as to whether the damage type is considered explosive, which is what one of the bonuses hooks into. And so that's still true, that's fine. Next, the speed of the shots. 0.6 is, I think, a little slower than the default. We can leave that at 0.6, that's fine. It also has a default, so we could just remove this line. Okay, jitter merge. What jitter merge does is when a weapon fires multiple shots in rapid succession, it makes sense that the inaccuracy of each shot isn't separate. So if it keeps on shooting, then one shot after the next will go inaccurate in something like the same direction, right? If you think about like firing a Gatling gun or something, it's not like one shot goes too far down and the next shot goes too far up, but rather, it kind of, the point where you're actually firing at as opposed to the point where you're aiming sort of wanders around. And what jitter merge does is it basically says what's the percentage of the previous position of the position of the previous shot that should be mixed into the position of the new shot. So if you set this to 1.0, which you shouldn't, then the inaccuracy will be consistent. It will just keep on firing. If it fired once too far down, it will always fire too far down. If you set it to 0.0, each shot will go wrong in a different way. So for something like a cannon where it gets reset and everything in between shots, that can be 0. But for something like a Gatling gun, it's really high. For this, 0.3 is actually pretty good. I might increase it to 0.5. Let's leave it at 0.3, because it's rockets in an individual pod and they will kind of go every which way. Okay, next thing is easier, reload. The amount of time in milliseconds it takes in between one shot and the next. Now this is going to be a kind of a rapid firing rocket, so we're going to say takes 1/3 of a second. The next thing is clip. That's just how many rounds of ammunition the weapon can store before it needs to be given a new ammunition resource. Like these the big rockets only could hold 1. Now here, one of the nice advantages that we're going to give this is that it has a clip of 10. So you can fire these 10 pretty fast, but they need to reload. Okay, let's say 8. Inaccuracy. This value is a bit weird because it's just so tiny. You pretty much have to look at what numbers other modules use, but 0.0065 is actually pretty inaccurate. Because, the big rockets are pretty inaccurate, and these small rockets are also going to be pretty inaccurate, so we can leave that the same. Blast damage is... So there's 2 types of damage in the game right now. Blast damage, which is more effective against wooden armor, and piercing damage, which is called penetrating damage in the data files, which is more effective sort of against steel armor. And so basically everything that goes boom is blast, and everything that just sort of punches goes penetration. In this case, the rockets go boom when they hit, so we're going to set this to, say, 12 blast damage. Okay, next question is the arc of fire. So you can specify basic direction, like forwards, back, up or down, and then the number of degrees the total arc has. So right now, these rockets have a forward arc of 180 degrees. For this rocket, these cluster rockets, I want to limit this quite severely. So one of the disadvantages it has is that you need to position your ship pretty precisely to be able to actually fire them. And what this means is that while they do quite a lot of damage and are quite nice and cheap and cheerful, the big downside is that you really need to put them on small maneuverable ships, because otherwise you're not really going to be able to maneuver into position. So we're going to take this down to 20 degrees, which is really bad. You can't, let's say 30, but you can't really move this pod thing very well. Okay, now we get to the things that traditionally cause people the most consternation. The muzzle center value. So what this is really is just the position relative to the top left of the module where a shot gets spawned when it fires. And this value is in tiles, which is kind of wrong, but so what. That's why it's this weird fractional value. And to figure out what this should be, we just go back into the graphics and we figure out, well, I guess a shot should get spawned about from this center here. And the offset there is 12 pixels horizontally and 9 pixels vertically. And if we just break out our loving calculator, we can divide 12 by 16 and arrive at 0.75. So the horizontal center of the muzzle is 0.75. The vertical center of the muzzle is 9 divided by 16, so 0.56. And then there's the muzzle length. So if you have something like a cannon, right, depending on which direction it's pointing in, the place where the cannonball actually gets spawned is going to be different, of course, because it exits out of the front of the cannon. So the muzzle center is really the center of rotation of the gun, of the barrel. And so if it shoots a gun, a projectile out of a barrel, it goes, okay, where is the barrel pointing? I'll start at the center and then I'll go out as much as the muzzle length, which is also in tiles for no good reason, and that's where it will actually spawn. Now in this case, because the rocket basically spawns inside this pod, the muzzle length is effectively 0. The next value is muzzle flash. Like if you have a rifle or a cannon or something, obviously it produces a flash and a kind of little explosion when it fires. This is a rocket and it doesn't. Next value is optimum range. This is the value in pixels now, which is the optimum range from which this weapon should be used. And this is just used by the AI. So the AI tries to maneuver a chip into a position where its weapons are within this optimal use range. And so the point is that if the AI has weapons which are very long range, it will try to fly away from you to engage at long range so you can't hit it and it can hit you. On the other hand, if it has short range weapons, it will try to close in. Now this is a really short range weapon, and so optimum range should reflect that. I'm going to set this to 50. So an AI ship equipped with these weapons will just go right up to you and then, use its weapons. That's how it's going to be effective. Okay, fire sound is the base name of the sound files that are played whenever the weapon fires. Now, in this case, I'm just going to reuse the sound from the rocket. But the way it will work, I can show you this in the data files, is that there's a sounds directory, and inside sounds you have, for example, let's find rocket. There. So there's rocket 0 through 5.org. So the sound files all need to be in org-vorbis format. If you don't know what that is, don't worry. Most sound editors can export into that format. And they have the base name plus a number, and then .org as their name. And so the way it works is that if you just have one sound, for example, you just have base name 0.org and you'd set this to 1. But here we have 6, so we have rocket 01234.5.org, and you will pick a random one of those to play. Okay, next thing is explode HP. So much like we had fire HP up here, this is the hit point value at which it might decide to explode. And well, it's rockets with explosives in them, so that could totally happen. And our basic hit point was 24, so we're going to say if it goes to 15, it might explode. And how much damage would it do? Well, let's say 24. As much damage as 2 rockets. Okay, nearly done. Now the final thing that we need to configure is the weapon appearance, which is all the information about what does the shot actually look like, and also what does the barrel of the weapon look like. Okay, so let's start out with the shot. This is another one of those images, and again the source here shouldn't be sprite sheet now, it should be cluster rockets. And now this here, because it's just an image and not an appearance, so whenever it says appearance, X, Y, width and height are going to be in tiles. Whenever it doesn't say appearance in the name, it's just going to be in pixels. So it's in pixels here. And so we just need the picture of the rocket, which is here. And we can read out the position of it. So it's at X equals 1, Y equals 20. Let me just turn that background grid back on. That will make it a bit more easy to see, I think. Width of 9 and height of 5. Okay. Now with the barrel. Now this is the barrel. But you might remember near the start I said I'm going to draw this a bit further to the right for a reason I'll explain later. Now the reason is that okay, so basically the graphics engine in the game in general just assumes that everything rotates around its center. All graphics rotate around its center, so if I want to rotate the graphic, it just rotates it around the center. Now in this case the center's sort of here, and that's a bit weird because it should really be rotating around here when it rotates. And so to fix that, we just make the total area we consider the barrel to be a bit wider. We take a bit of empty space to the left, and that moves the center of it around which it will rotate to be like in the actual barrel here. And a lot of barrels in the game have this thing as well, because most of them don't rotate around their actual center visually, but rotate around something that's a bit further to the left. Okay, so we now have this. It's going to rotate around this point. We can just read out these values again. And indeed, the source, of course, should also be cluster rockets. Okay, so X coordinate is 18, Y coordinate is 15, no, Y coordinate is 20, width is 15 and height is 9. Okay, now we come to the bit which I apologize for because it's incredibly confusing, barrel X and barrel Y, which is, it now wants to know, okay, we know mechanically where the shots come from, but where do we draw the barrel? Which is a slightly different question. And the answer is, well, if the barrel was at 0 degrees, it was just pointing straight forward, what's the offset from the top left that the barrel should be drawn at? And you can essentially answer that question by going, well, okay, where's this shot center? Well, we said the center was going to be at X12 and Y9. And then we subtract half the width and half the height of the barrel image from this value. And that gives us the top left corner of the barrel if it was pointing straight forward and its center was on top of the center of the actual of the rotating barrel. Okay, so the X here is 12, and so we have 12, and then we know that the barrel image is 15 pixels wide. So we subtract 15 divided by 2. And that gives us... No, that didn't work. Sorry, this calculator is really bad, apparently. Sorry, okay. We divide 15 by 2, right, and that gives us 7.5. And then we do 12 minus 7.5, and that gives us 4.5. So the barrel X is 4.5, and barrel Y, we look back here, the vertical position of the rotation center is 9, and the total height of this is 4.5, is 9, so we divide 9 by 2, that gives us 4.5 again, we subtract 4.5 from 9, that also gives us 4.5, so as it happens, the X and the Y are both 4.5, and that's where the where this thing should be positioned, so roughly like here. So you can see if you move this and superimposed it onto this, then it would be kind of positioned correctly. Okay, next thing is what sort of stuff spews out of the shot when it's fired. And we can have both a shot emitter and an exhaust. They're both particle sources. So the shot emitter, we're just going to trail some smoke. So this is a reference to a particle type, which is another thing you can create new things of. Here we're just going to reuse trailing smoke. And this is the emit probability, which is the probability per millisecond that it's going to produce a new one. So don't set this to 1, because that will produce a lot of smoke. In fact, we're going to halve it, because it's a smaller rocket. And then the exhaust is another particle source, but instead of just producing stationary particles, this actually shoots particles out of the back of the shot, which is sort of what we need for this. So here, the type of particle we produce is called rocket exhaust. The probability is 0.1 per millisecond, so we're pretty much just going to spew a lot of them. Here, we're going to halve this again. Back offset is how many pixels back it should actually spawn them from the center of the shot. So in this case, because our rocket is 9 pixels long, we want a back offset of 5. Angle range is the angle in radians of how wide the angle it can be in terms of where it actually spews out the shot, the exhaust. So if we set this to 0, the exhaust would go in a perfect line. If we set this to like pi, it would go anywhere up or down or anywhere back. If you set it to 2 pi, it will literally go in any direction. Here we're going to go for like a little bit less as well, like 0.2. Random offset is also just a number of pixels. It will randomly offset it in any direction. So the point is that if you have a big, imagine a really big rocket with a really big exhaust, then not all of the rocket exhaust particles should come out of the like center of the exhaust. Some should come further up or further down. Here our rocket's pretty small, so an offset of 1 will do. Finally, speed minimum, speed maximum is just the minimum and maximum speed that it will actually create these shot particles at. So if we increase this, the exhaust is faster. We can leave it with these values. Okay, and that's everything that we need to define this module. So we defined basic information about like what it is and what category it goes into. We defined its size and its appearance, information about its hit points, how long it takes to move through it, its weight, its cost, what it needs to be crewed. Then some basic weapon information like how much damage does it do, how accurate is it, how fast does it reload, and so on. And then information about where do the shots come out, and then information about what does the barrel look like, and what do the shots look like, and what particles do the shots produce. Okay, and so that's everything we actually needed to do to define this. Now there's one more thing which we have to define before we can try out the Class 2 rockets, which is the sprite sheet. So this is the little piece of information that ties together me saying Class 2 rockets here and this actual image this actual set of images of cluster rockets here. And that's we just need to create a little record that ties these three things together into a sprite sheet called cluster rockets. So that's what we're going to do next. And to do that, we go into the cluster rockets directory and we create a new directory called sprite sheet bundle. And then in there, we're going to create a new file. Which we're going to call, I guess, clusterrockets.json. Okay, and this contains one record. So all of these files for various entities always contain a list of dictionaries, and each dictionary is a record. It always has a name and it has some other values. So in this case, the name of our sprite sheet bundle is cluster rocket. So this is now actually both the name of it and also reference to the file name. So the name of the sprite sheet bundle should be the same as the file name. So you leave off the PNG at the end and then you say bump is cluster rockets bump, again without the .png, and fragments is cluster rockets fragments. There we go. And so now we have a sprite sheet that is composed out of both the actual picture, the bump information for the lighting engine, and the fragments. So that just needs to match the names of these three files. Okay, now we've done this, we have the graphics for it and the information for the module, and we've tied the two together. So we can now actually try out a module. There's still a bunch of things missing. For example, we don't have any descriptions for it. We also probably want to give the AI ships with this module in to actually build, and a bunch of other things. But we're now at the point where we can at least functionally try it out in a game. Go into settings, mods. Now we delete the old version and we install cluster rockets again. It regenerates the graphics, so it's basically creating pre-compiled version, you could say, of the graphics we've created for particular lighting conditions and stuff like that. It's also generating damaged versions of the graphics and all of that kind of stuff. Okay, so now here we have it. It's actually published. Now we can try it out. So just go into Design and Fight Airship Editor. And if we go into Weapons, we should see, there we are, our cluster rockets. Now you can see the name looks a bit bad, but that's just because we haven't actually put in the proper name for it yet. That's something we're going to do next. But let's just select it. Put it down. And now you can see what it looks like. And as you can see, we did the calculations right. The firing arc looks right. The firing arc is centered on the box with the rockets in. The box with the rockets is in the right place. And so that's looking pretty good. Right. So next up, we're just going to do all of the things that we still need to actually finish the mod, so it has all the components it wants to be fully featured. The first thing we really want is actual name and description for our module. So we'll create a new folder called strings. And in here we create a file called en.properties. So Airship supports multiple languages. At the moment it supports English, German, French and Russian. You can you don't have to have translations for all of those in your mod, of course. If you just have English, that's fine, whatever. But the way all the translation keys are handled is that in the strings folder, there's .properties files with the language code in front, so en properties, fr properties, and so on. And they are properties files that map the translation keys to the actual text. So what we need here is we need mod cluster rockets. So the name of the module, which is cluster rockets. Then mod desk cluster rockets. Something like and then we want essentially the same thing again, but for the flipped versions. Because the flipped version of the module is really a separate kind of module. It's just derived from the previous one, so it needs its own translation key. Okay, and that gives us the actual translation for it, so it will now appear with the proper name in the game. Okay, now the mod's complete. The last thing we want to do is actually publish it to Steam, which we do from Airships itself. So install the newest version of it. Then we can simply publish it by selecting it and hitting publish to Steam. It regenerates the graphics one more time and then it uploads and publishes it to Steam. There we go, and now you'll be able to find it in the Steam Workshop and subscribe to it. Just to quickly look at some other stuff to manage your mods that you've created. If you delete your local version of the mod and you want it back from Steam, you can hit download published items and that will re-download from Steam everything that you published at one point. If you have a particular mod that you changed locally and you just want it to be reverted to the version from Steam, you can hit sync from Steam. And of course, if you've improved your mod somehow and you want to update the version on Steam, you hit update on Steam. The important thing to note is that if you hit update on Steam, that will then percolate out to all of the users, so kind of don't press that by accident, right? And then finally, if you're not using Steam at all, you can still do modding. It's completely separate. You can just hit export the file, and that lets you create a .amod file, which is just a file containing the mod. It's actually just a zip file with a funny extension, and the game also sees that as a mod for installing, and so you can just share that file by email or with a file sharing website or something like that, and that lets you share mods even if you're not using Steam. Okay, that's all really. That's how to create a mod. The final thing we should really do is actually try out our new weapon, right? So let's just do that. Let's start a fight and let's see how it actually does. Yeah, so we immediately have this thing where we need to maneuver pretty hard. Ooh. Yeah, I think the answer is this is a bad weapon if your opponent is has a better service ceiling than you do. Yeah, okay, so we so lose against that. Let's try something else. Let's try this thing. Well, it's still doing its best to position itself, but if we go close, then yeah, our weapons are kind of effective. Okay, this needs a lot of player attention, as I can see, but assuming you can keep them actually hitting the opponent, they work very well. So I think that's a good trade-off. Yeah, victory. Good stuff. Okay, that is all. Thank you for watching. If you have any questions at all, leave a comment or feel free to ask in the forums, or indeed just follow me as a friend on Steam and ask me questions in Steam chat. I might not instantly respond because I'm busy, but I will respond, and I'm very happy to walk you through any problems you have with modding.